Well, cool. So yeah, first, welcome everyone. Really excited to have you here, and want to say welcome for Bilal, and let's all give him a warm introduction here. I'll let you maybe talk a little bit more about yourself, but you're coming all the way from India. What part of the country are you in?
Mumbai.
Mumbai. Nice. A lot of traffic, right?
Yeah.
Well, awesome. So it's super late for him, which is why we're doing it a little bit earlier. But yeah, thank you so much for joining. I feel like you're a face I've seen around the ZIO community for a while, kind of contributing different things, doing different things. And I know you've been working on this particular library, ZIO Maelstrom, and I also feel like distributed programming is kind of a really interesting area and something I think other people are interested in. So yeah, I thought it would be really fun to have you on and kind of hear about what you've been doing and get a chance to show this off a little bit.
Sure. Thank you. Right. So I'll start with a very small introduction. I'm Bilal Fazlani, and as Adam said, I'm from India, Mumbai, and I work for ThoughtWorks as a developer team lead. And in this session, I'll be talking about distributed systems and some fun ways to solve them using a library which I've created recently. All right. Let me start by sharing my screen.
Yeah. And everyone, if you have any comments or questions, post them in the Discord, and I'll try to check in on that as we're going, and I'll kind of feed those.
Cool. All right. So some weeks ago, I think I came across these distributed system challenges on fly.io. I think they teamed up with Kyle Kingsbury to come up with these challenges. And initially they used this for their recruitment and hiring for their interviews. And I think a couple of months ago, they just made it public because it's too much fun to solve these things. They have their official Go library to solve these challenges, and I think there are some open source Java libraries as well. And the one that I created uses Scala and ZIO. By the way, if I go too fast, just let me know, and I'll slow down. Okay.
Perfect.
Sure. So yeah, so these challenges are distributed system challenges, and in the sense that they require multiple nodes and applications running on multiple nodes. And these are not the nodes typically your Kubernetes nodes. In this case, they are running on the same machine, but they're talking via std-in and std-out, basically standard in and standard out. There is a tool called as Maelstrom, which is again created by Kyle Kingsbury. It spawns up the applications that we create and routes the traffic using the standard input and standard output. And it does that because it can then get control over the traffic. It can monitor the traffic, and it can bring in downtime or network issues intentionally to see how our applications behave when there are network delays or partitions. And libraries such as this Go and the one that I created do the job of abstracting away this standard input, standard output, and gives you sort of a network IO interface. So you won't come to know whether you're interacting via this standard input and standard output. All right, let's take a look at the first challenge. And I think by doing that, it's sort of a setup challenge. It doesn't have anything related to distributed systems, but completing this challenge will give us sort of a introduction to what this library is about and how we'll solve the next challenges, basically. I'm hoping that we'll be able to solve a couple of very easy challenges today, and maybe a couple of medium level challenges as well. And let's see, like depending upon how much time permits, we'll see how far we go. Um, all right. So the first challenge is called an echo. Um, so here we will be asked to create a node, one or more nodes basically, which just echoes whatever comes to it basically. Um, you can see on this, my screen is visible, right? And is this font sufficient enough? Okay, cool.
Yeah, I think it's good. Definitely, anyone on the Discord, just message if it's too small, but it looks good to me.
All right, cool. Uh, so before we jump right into the code, let's take a look at the protocol that we will have to follow throughout these challenges. All right. Yeah, this is the same introduction, I think, which I gave in brief. These are some node IDs. So whatever applications that we create, uh, they will be labeled as N1, N2, N3, etc. The node IDs. And there are some Maelstrom nodes which will send the request to our nodes. They will be called as C1, C2, C3, etc. This, well, let me make it slightly bigger. Yeah, this is the standard protocol with which we'll get these messages. Those will be JSON messages. And so there will be an SRC which will contain a node ID, either C1, N1, etc. A destination will be another node ID, which will be the node on which the message is being received, and a body. Body will be a JSON object, and we'll have to parse the JSON object depending upon what type it has. Optionally, there will be a message ID. Message IDs are useful in case you want to reply to a message. And when it is a reply, you will have in reply to, which will contain the message ID of the original message to which a reply is being made. Right. With this, let's take a look at the echo. And with echo, Maelstrom node will send us a message of type echo with message IDs and echo, and it will expect us to send something like this. So it expects us to send a message with type echo OK, a message ID maybe, and in reply to one or whatever was the original message ID, and the same message that we received. The implementation detail on this page is mainly going to be in the Go language, so we can ignore that for now. Right, and there is some setup information about how to install Maelstrom. This is going to be a prerequisite. I have all of this done, and so I'll not go into detail. I have a documentation page which maybe we can share a link for that later, and then we can follow those things to install all these pre-requirements.
Yep. I'll also share the link in the Discord for folks while you're going.
Cool. So the easiest way to start with this thing is to use this repository. I created sort of like a template. Similar, its job is similar to what Gitterate does for Scala. So we use this template and we create a new repository. It does take care of a lot of boilerplate scripts and all. So let's call it, Maelstrom Zymposium. Okay, I'll keep it public. All right, so we have our repository, skeleton repository ready. It has empty folder directory structure for all the challenges and the scripts to compile and run all these challenges. Basically, there is no logic or code here, just some scripts. I'm going to clone this now. All right. Okay, I had tried one earlier. Let me remove that. Okay. Okay. Let's open it. Okay. Okay, I think my system is acting a bit slow. I'm gonna turn off my camera. Is that okay?
Yeah, definitely. Yeah, I think we're probably more focused on the code anyway.
All right.
I'll do the same.
Let's import this. Yeah, so as you can see, these are all empty sub projects pre-created for us. And they all also contain the parameters which are required for each challenge, basically. We'll go to echo while this is loading. I think I missed talking about one protocol. Yeah, the initialization. So as soon as Maelstrom starts our node, it sends an init message, and there it tells us what is our node ID or the node ID for that node, basically, and all the node IDs in the cluster, including itself. And we are expected to send an init OK with that message ID to that message. Only then it will proceed with the subsequent messages.
And in these examples, are there going to be cases where the network topology is changing? We're going to be adding or removing nodes, or is the assumption these going to be that we have the same nodes throughout?
Yeah, they're going to be same nodes throughout.
Okay.
But
Got it.
Yeah, there may be network partitions though. So somewhere in the middle of the simulation, you may suddenly not be able to reach out to one or more of these nodes.
Okay, got it.
Right. So the init part is taken care by the ZIO Maelstrom, and we don't have to worry about that. Let's see how it works now. So we begin by defining the protocol using case classes. Case class echo. That's the first message that we are going to receive. It's going to have an echo, which is a string. It needs to have a JSON codec. Right. Let's import everything already that we know is going to be required.
And so we're using some Scala 3 goodness here, I say.
Yeah. Is this still importing? Okay, no. Okay, so we have this thing, and okay, that's going to be our response message. There are some basic requirements to use these protocols. One is that, so this response message, or let's talk about this request one, it needs to extend needs reply. Yeah. And because it extend needs reply, it needs a message ID.
Message ID, got it. Yeah.
And this is one of the primitive types from the library. This needs to extend extendable and a reply. And because of that, it needs to have in reply to and a type. and in reply to. I'm just using the same field names as JSON, as the protocol. Yeah, I think that's it. These are the things. Let's define. So because of this import, we have lots of things available with us. Let's create a handler, a message handler basically. And it is done using, we are getting a lot of things already.
I know this is sometimes the problem I have when I do these, because I have the Copilot too, and like I'm trying to incrementally do things. It's like, oh, here's the answer.
Yeah, sometimes it kills the fun out of things. Yeah. Right. Okay. So yeah, I learned a lot from the Zymposium videos, and especially the things, I think in one of the Zymposium videos you talked about partial application of these type parameters. So I've used that
Nice.
here. So yeah, case echo.
Yeah, and for the folks from last time, this is also an example of we're defining something using a partial function here. So
Correct. Yeah. Right. We don't have to. We should specify it here. We don't have to though, but echo, because that's not going to change. Right. So here, what we are doing is we receive this message. There is a function called as reply. It's a context function using Scala 3, so it knows the source of where the message is coming from. And you specify the message that you want to send. It returns a ZIO. And that's pretty much it. It's this is it. If you look at the syntax, it requires a runtime. So let's try and run this handler. We need to provide that runtime. This should put. I think it compiles. Yeah. So let's see if this works as expected. Ideally, we need a type here also, but we are not, because there is just one message, so there is no JSON type discrimination that we need. So I'm not using any type here for now. But when there are more than one type of messages, we are going to start needing the type here as well in the input message.
And then we would extend sendable there as well.
Well, no, for the input, we don't need to, unless it's the input as well as output. Then we need to use sendable. If your node wants to send something, then only it needs to extend sendable.
Okay.
Okay. So let's see if this console, right? Okay. Let's get into SBT now. I'm using this this example just to showcase the scripts and all the boilerplate that is already available in the template. Let's see. Okay, we're in. If we go into project echo, we have these commands available to us. I'm going to use bootstrap, and it will create a fat jar for us using the Coursier CLI. Along with that, it will create a bash script, and we'll take a look at that once it is ready. Okay, let's see what do we have here. In the target, we have the echo.jar, and we have testjar.sh, and it's calling Maelstrom test. The binary that just got created, like the current directory and the echo.jar, with -w, which is echo. So it's telling Maelstrom that it wants the echo payload with one node count or one instance of our application, and for 10 seconds. this is same as what is expected from this challenge here. Every challenge has different parameters basically. So what I've done is taken all of these and put them in their respective SBT project as configurations. So we can go here and right echo target, and we can just simply run this and we'll see if it functions correctly. It seems to be receiving and sending the messages correctly.
That's really cool. Yeah, it's nice because I remember a while ago, Kit and I did like a couple of like kind of distributed type things, and we ended up having to build a lot of kind of the like infrastructure, quote unquote, of like, I mean, it was all on one machine, but the concept of different nodes and nodes sending messages to each other and processing the messages. And this just kind of, obviously it kind of takes care of all of that. So you can focus on like the logic of what you're handling versus implementing that yourself.
Right. That's why I found this a lot more fun because it only lets you focus on the core part of it.
Yeah, exactly.
Let's run one command. It's called Maelstrom serve. It runs a server wherein we can see, let's see. I think it's on 80. Yeah. So it will start listing down all the run instances. Here we saw that it says that everything looks good. Sorry, it says everything looks good. That means it has passed the test. And to know more details, we can go inside this, and it has all kinds of metrics, logs.
Oh, that's cool.
And each in the logs of each node basically. So in this case, it was just one node, so we can see it outputted just this small little log here. But we can also see messages. It's an SVG file, and
Oh,
this
that's really
case,
cool.
right? So it's messages from C2, which is a Maelstrom node, to N0, and it keeps on going.
Yeah,
This
I mean,
will
here
be
it's
more
super
useful.
simple, but yeah, when we
yeah.
do more complicated things, this will be really cool.
Right. Okay, so I think we are now ready for the next challenges. Unless anybody has any questions.
Yeah, I think people are good so far.
Okay, let's jump into unique ID generation. In this challenge, we are going to get a message called as generate, and we are supposed to return generate OK with a unique ID. And this is the evaluation criteria. The payload is called unique IDs. 3 nodes will be spawned, and I think probably we'll get 1,000 requests per second or so for 30 seconds constantly, and availability total message partition. This means that there's going to be a partition somewhere for a few seconds within the 30 seconds. The unique IDs are supposed to be unique across the 3 nodes, right? Otherwise, it will fail the test.
Got it. So I have a little more work to do this time.
Yeah. Let's see. Let's see. Where is this challenge? Unique ID generation. Right. Okay. Import. All right. Let's start with the case classes. We have what was it? Okay, I think there is no parameter here in this case. So device using codec and extend needs reply, and for that it needs the message ID. right. And it does not need a type. Yeah. In class generate. Okay. This will have ID, which will have to be. This says that IDs may be of any type: strings, booleans, integer, floats, and arrays. Uh, so
Just as long
let's
as they're
go with
unique.
yeah, yeah. So I think I found strings to be very easy to implement because I solved this problem some times ago, and the strategy I used was I just had to make sure that the IDs are unique from one node because I kept prefixing the node ID to them, and that's what made everything unique. So let's go with that. String in reply to is message ID type generate. Okay, fine. Sendable reply is correct. JSON coding. Yeah, this generated correctly. And let's see. We'll have to create a handler here as well. No. Okay. So we have some context functions available with us. Me
Ooh, fancy.
is one of them, and it gives you your own node ID. So let's reply.
And so this receive method is giving you an implicit context as well. Is that right?
It is, yes, yes.
Yeah. So that's another kind of Scala 3 fanciness. Very cool.
Yes. I have used many of them. I've also used exports. I don't know if I'm doing right, but it was fun. But yeah. Yeah, ID. So let's go with I don't on mean and underscore. I think I'll just disable this copilot because
Sure.
okay. And then oh wait, we'll need some kind of state here. Or we can use rand. We have two options. For the IDs, we can use ZIO.random to keep appending something here, or we can use a ref of int to continuously keep incrementing something. Let's try the random thing first and see if that works.
Okay.
Right, ID random dot next int. Let's go with int dot max value. Why am I still getting the auto completion? I have disabled it.
That I'm not sure. You might need to restart or something, but I don't know if it's worth it now. Up to you.
Okay, I think it's disabled now. So we have an integer now, and ID int, and I think we can now reply. Reply rate. Okay. $mean underscore $ID int. Yeah. And that's going to be the message ID. Type I don't think we have to give. This should work. What did it mean? Oh, okay. Right. So here we are using a random prefix with the node IDs. Hopefully this should make things unique.
Yeah.
Handler dot provide will use the same commands as earlier. These things will be sufficient for some easy challenges. But as we go on, we'll have to make use of Graal VM, because when we have to spawn 25 JVM nodes all at once with very high response time, I've found jars don't work well. Okay, so we have created unique ID generation.jar. If I can go here now, target and test jar.sh. Yeah, let's see. Okay, seems to be working so far.
Yeah, I think theoretically we have the possibility we could generate the same random integer on one of these nodes, but statistically it's probably unlikely for the sample size, but we'll see.
Yeah, correct. I think this will, okay, yeah, it's done. Let's see. Oh, okay, cool, looks good. Yeah.
Nice.
Okay, let's take a look at the next one. I think these were the most easiest ones. Right. So we are now entering into this challenge category of broadcast.
The non-trivial category.
Yeah, yeah. So this challenge number 3 has 4 challenges within them. 3A, B, C, and D, and they get very difficult, especially the C and D. Let's see. And it builds on incrementally. So here we'll get the first message as topology, where it will give us what's the topology, basically all nodes and their neighbors, and it's going to be in the form of a map of node ID to a sequence of or a set of node IDs, which will represent the neighbors. And it will send a broadcast message. So this message will be just once on the startup of the node, and then it will keep randomly broadcasting some numbers to different nodes, and those messages will be integers, and it will then read from these nodes. It will expect that these nodes are all synchronizing these numbers or messages among themselves. So it is expecting an eventual consistency, basically. So it will, let's say if there are 3 nodes, it will send this broadcast to node 1. But if it reads from node 2 or node 3, it will expect that message will be sent as a response to it. Maybe because of some gossip or something.
Got it. So we're going to have to figure out our algorithm here.
Yeah. This particular thing is a single node broadcast. So there is no broadcast happening in this challenge, at least. And we'll build from here. Unique ID generation and single node broadcast. Okay, let's start with again the protocol. Topology. What does it contain? It contains a field called as topology, which is a map of node ID to set of node ID. Oh, I missed the imports. This should do it. Okay. Oh, here now, because there are multiple types of input messages, we are going to need a field hierarchy.
Yes. Okay, and we just do that the typical Scala way. Yeah, nice.
Yeah. Right. Let's do it JSON decoder. Okay, yeah, it just needs more things. Hopefully, yeah, it should make it happy. This topology needs a reply. So a message ID. And I think here we are going to need a JSON discriminator called as type. And here JSON hint. This is called topology, all lowercase. And that should be it. Let's move on to next. Message is broadcast with just one message of integer, I think. Or less message. And this also needs a reply, extends input message and needs reply. All right. Yeah. And a read message, which doesn't contain anything, but does require a reply. Oh, I'll have to use this everywhere. And this should contain only this much, I think. Right. So we are done defining our input messages. We'll have to now define output messages. So topology, okay. Which is nothing, just nothing. Topology, okay. It doesn't say here that it needs to have a in response to or in reply to, but they have omitted it, but it does need that everywhere. So we need that. It's a sendable reply. So it needs in reply to message ID and a type, which will be topology. Okay. Then there will be broadcast. Okay. This is the part where I missed the GitHub Copilot. Okay, yeah, nothing again, same. And a read okay. So read okay needs to have the answer, basically all the messages that this node knows about. This is going to have all of this. And it's going to have messages. And I'm going to keep it a set just to avoid any duplications. And it's going to be set of integers. And we're done specifying the protocol at least, hopefully. Okay, let's try and define how our receiver looks like. Uh, right. So yeah, receive can take this parent interface. And going to start with let's start with topology. When this challenge, I think we can ignore the topology. So we still have to send an okay though. So let's reply topology okay without storing the topology. Oops. That's going to be t dot message ID. And that's it. Oh, what happened? Oh, we did not derive anything. JSON encoder. Right, all of these are going to require JSON encoders. Right. Case broadcast. So we need some state at least now. And we can do that using some ref because all these messages are going to be concurrent, and can use Z layer to inject state.
Nice.
Let's
Yep.
So let's start with state. That's going to be CO, or yeah, let's we can do it anyway. Basically. CO dot service. Am I doing something wrong? Oh, okay. I think I know. Right. Right. Service with ZIO. And let's take a ref of set of integers in case we receive anything duplicate. And we will update it v dot message. So we update it. And after that, we reply broadcast okay. And reply to t dot message ID. And the last message is read. This is going to be Again, I think this one. Get, right? It gives me all the integers, and it can do flat map on that, and then reply. Read okay, and reply to dot message ID. And numbers. Just set. This should do it. Okay. This handler now requires a runtime as well as a set of integers. Handler dot provide and that's, if I remember this correctly, set dot empty. Oh wait, am I doing it? Yeah. Am I doing it right? Oh, no, I have to use Z layer dot from ZIO and then do it. I'm still missing something. Immutable set of Scala integer. Oh, okay. Yep.
There we go.
Right. So because this challenge is going to start only one node, it's going to query and very easily get those numbers because we are simply updating. But let's see if this works. How many nodes does this start? It's going to, okay, yeah, this just one. 20 seconds and 10. Right, let's try. Single node broadcast. Just okay. The challenges get more difficult, not just with the functionality of what it wants to achieve, but also sometimes with the number of milliseconds in which they expect a reply.
Performance
And
actually
that,
becomes important in addition to just correctness.
yes.
As in real life.
Yeah. Okay, let's see. Single node broadcast target and what's it called? Test. Yeah. Right. Seems to be working fine so far. So the message size is now increasing. Yeah. Okay. This was a pretty simple one. For the next one, which is a multi-node broadcast, I think the only difference in the evaluation is the node count. But now we have to think about how are we going to synchronize these numbers across these nodes. I'll start with copy pasting this entire thing, and then from there we'll modify this file.
Okay.
What's it called? Multi-coast. Okay. Yeah, I think this is the challenge from where all the fun begins. So far, it was quite boring, no distributed at all. Um, so, uh, I'm not a distributed systems expert, and so my most basic strategy here is, as soon as I have a topology, so first thing I do is I'm going to need to store this topology where I know that these are my, like, who are my neighbors whom I should be sending my numbers to, and then keep doing that as and when I keep getting these broadcasts, and I expect other nodes also to send me those messages, and that's the gossip message. Our gossip message in this very naive implementation is going to get larger and larger with time, and in this challenge that will not be a problem, like, because it doesn't have a lot of restrictions. Let's try and see how it looks, right? So I think these messages are going to be exactly the same, and uh, apart from this, for the first time now we'll introduce our own custom messages that we are going to be sending from one node of ours to another one, right? Gossip. Oh, let's I think begin with first defining a state class, because now with we just don't need this set. We also need to store the topology, so we need a case class. State topology. So in with topology, we get, if we look at topology, we get a map of node IDs to another set of node IDs, right? I don't think we need the entire map stored. We only need to know what our neighbors are, right? So we can just store the neighbors instead, actually. And also our own numbers, which is again a set of integers. That's our state. When we receive this topology, we'll have to store it. ZIO dot service with ZIO ref of state, and we'll update it. Uh, it's just the neighbors that we want to copy. I think I can very safely use this. But why is it failing? Oh, did I? I think I know I read. No.
I think you just want ZIO.service, right? You just want to grab the ref, and then you want to,
Oh,
I think,
yeah.
ZIO.service.flatmap. I mean, we could do the service with ZIO, but they're both fine ways to do it. So I think just ZIO.service.
Service.
Yeah,
Or
that'll
service
just
with.
give you the.
Yeah.
Then you want to get rid of the map. Yeah. And then you're going to want service with ZIO, I think, because the update is going to return a ZIO.
Oh, yeah.
Yeah. So yeah. Both ways are fine. Just need to be consistent. Yeah.
Correct. Right. And these are topology. Finally, yes. Right. So we have updated our topology, and now here after that we reply okay. Yeah, it will start crying now because ref dot make state set dot empty set dot empty. This should work. Hopefully. Yeah. Right. Everything. Broadcast when we receive a new broadcast. Um, we want to update. So this is going to be state ref of state, and there's going to be a copy now, right? Copy and numbers. Well, wait, I think I need to. Yeah, I can't use the underscore. I think here, right?
Right, because you want to reference it twice. Yeah.
Yes, yes. Numbers plus. Do I have a new number? Yeah, broadcast b dot message, and that should be it. I think this is sorted now, right? I am updating with the number. Yeah. With the read, again, I need the state. Get flat map. Oh, this is the state now. State dot numbers. No, yeah, okay. Yeah, so this will fail now, with although it's compiling, because we haven't done anything to synchronize things. Let's start working on that. So we are saying we will on broadcast, we will send a message to all the neighbors, and they will receive it. Let's call it gossip. That message, because it's going to be part of this receive, it needs to also extend in input message. Now there's a choice that we can make here, whether we want an acknowledgement or not. If we want an acknowledgement, we can use this and then have a message ID in it. But this challenge does not bring any partition. Even if it did, we still might not need it because we are sending the entire payload. So even if there was a partition, and if we miss a few messages, those will get covered in the next gossip that we do, right? So we don't need an acknowledgement here, sort of like a UDP. It will have number, and it will need to derive some codec, because we'll send and receive this. It needs to be sendable. Oops. And so it needs to have a type. Okay, I think we are okay now. Right. Yes. So whenever we receive gossip, well, we have not sent it yet, yeah, but we'll let's say we receive a gossip. What do we want to do? We just want to update our state with it. That's all. So ZIO.service with ZIO ref update update. Oops. Next is the state, I believe. Yes. Dot copy numbers. X dot numbers plus v dot number. I think. Oops. Yeah. Okay. So the receiving part is sorted. We simply updated. But broadcast. Now there are subtle differences in what we choose here. We can decide to send a reply uh, after we gossip, or send a reply before we gossip. I think for this challenge, yeah, let's go with we gossip later. So there is a send API. Send will take a sendable and will return a zero. Pretty simple actually. So gossip and the number that we got. Wait, send API works like this. We have to send it to everyone, right? So yeah, I need a topology here. Yeah, the neighbors. ZIO dot service with ZIO state dot doing something wrong. Get oh neighbors. Am I probably doing something wrong? Service with, I think.
Is neighbors, is that a ZIO workflow or is that just a value? Yeah, it's just a value. So yeah.
Yeah.
And this is also, I think, I mean, we're just doing this as we go, but if we spend a little more time on it, we might want to extract this state into its own, this ref of state into its own service that had like named methods. So we didn't have to do the service with ZIO all the time. But I mean, it totally makes sense what we're doing right now.
Yeah. I feel that. So basically, I think in the next challenges we'll have to do that. Otherwise, it becomes like very complicated to even look at. Yes. I think we can start doing that immediately after this. Right. So we got neighbors, and now we can do. Yeah, this is where I really like an ZIO basically, because it almost feels like cheating, because the amount of constructs you have is too many basically, and it multiple ways to do same things. You can decide how much concurrency you want, what kind of safety you want. So we can do merge all, or for each par, let's say you can do for each par, right? And you can give it right, and you get each neighbor here, and n here is a node ID, so you can do n send gossip b dot number or b dot message, I think. Oh, right, that will give what exactly? Just a single ZIO. We are good, I think. So we have already replied, and after that we are doing all the gossip with parallelly. I think we are okay. Even if this doesn't succeed or something, we are okay. Why is this crying? State. Am I not? I did pass the state. This is the state. Oh. Yeah. Mistake. Let's get dot map. Here I have to do with ZIO. And then map. Yeah, it makes sense to extract messages and extract methods there. Neighbors. Come on. Yeah. Okay. Right. This will. Yeah. Let's see. We'll go into project multi cast and bootstrap. Oh, I think I made the wrong method. I can't stop it, is it? Oh, no. Bootstrap. Right. Multi-node broadcast target test chart. The count is increasing, so it feels like it is working. Oh, nice. Analysis invalid.
Failure.
Good. Okay. Let's try and take a look at what failed. Yeah, so our most recent broadcast has failed. Results. What does it say? Lost latencies, stable latencies. Never read. Okay. Stale. Lost. Oh, the lost. These many lost, is it? What did
Yep,
we do
lots
wrong?
lost.
Okay. Let's try and take a look here at the messages, maybe. Oh, so we from C9 we're getting a topology, and everybody is getting a topology, and everybody's sending a topology. Okay. Read, okay. Read okay. Thing. And this guy's sending gossip after it received broadcast to this, and then read gossip. This guy sending a gossip here and a gossip here and a gossip here. It looks okay from this diagram at least. Let's see if node logs. Okay, we don't have a lot of logs here. We can bring some logs. What's happening? We get a broadcast, and okay, I think we should try this. We reply broadcast okay after we are done, gossiping. Let's try that. No, maybe it helps. It should not, because it's eventual consistency that it is looking for. Right. Did I mess up something? Update copy numbers is I did update on the gossip. On the broadcast also I did an update. Yeah. And I'm sending to all the neighbors of my neighbor. Yeah. Okay. I'll try this one more time with this slight change that I made here. And I'll also do one thing. I'll add some settings. So you have a lot of configuration options here. You can set concurrency, log format. I'll set the log level to debug. It's info by default. And let's see. Okay. Multi-node broadcast. What's the command it's executing? It's executing broadcast node count 5 timelet. Yeah, it's pretty relaxed, whatever it needs basically. Oh, I think I know what's going wrong. This will fail, yeah. So we are not sending all the messages, right? I think we'll need to send all the messages. We are just sending the broadcast, but we may need to send all the messages, not just that broadcast. Right, so this will be number. All the numbers that I know of, basically. Right, and so we updated the numbers. We gossip. Do I have the state somewhere? No, I need to refer the state again. v.x.numbers. And let me get the state. Right. If I do that, would there be any concurrency challenges? Should not. ZIO dot service with ZIO ref of state dot get dot map numbers. Right, that's my numbers. And here,
I think if you're getting it here and then on the next line you want to update it, I think you do maybe have an issue
with
there.
so it might have
Right, you
stale,
probably want
right?
to combine those. Yeah, you probably want to combine those into one, like modify.
Oh
And yeah,
yeah,
we are kind
right.
of getting to the point where we, it's definitely feeling like we want to extract that ref state into a service.
Yeah, let's do that.
So we're
I think
also
it'll be
getting
quick.
long on time here.
Yeah. I think it will be quick.
Okay. Yeah.
So state def update takes numbers. And it dot service ref of state. Update should give, should ideally give, no, it should not give anything, right? Or should it? No. It doesn't
If
need
all
to
we want to
because- yeah.
do is update, then we don't need to return anything back, but well, unless we want to have, you know, like the old state. So I mean, we could have something like get an update.
Yeah, makes sense. Update and get something like that, or get an update.
Just depending on whether the state we want to return is the new state or the old state. Yeah.
Yeah, you're right. We want the new state. Update and get. It requires, it gives me old state and wants new state. Start copy. Numbers. Equal numbers as dot numbers plus this numbers. Yeah, this is pretty useful.
Yeah, it's
yeah.
I know once you extract it out, you're like, oh, that's good. That was nice.
Right. This is where we're doing update. So I'm going to get state dot update and get b dot numbers. So here I only have one. So I'll say set of b dot number or b dot message. Yeah. And I get the new state here. Neighbors is fine, I think. I have the state and I'm sending that. What is this state?
Well, then I think we can just get the neighbors out of the state instead of getting the state again, right? On line 42.
Where would you put the neighbors if you put them out of the state? Oh, another state, is it?
Well, no, just you already got this. You got the new state on line 41.
Oh,
right?
yeah,
So
yeah,
on line
yeah.
42,
You're right, you're right.
you don't. I don't think you even need a ZIO effect. It can just be like neighbors equal state dot neighbors. I think.
Correct. That's nice. Okay, compiling. What's with this now? Numbers. I think. Oh, yeah. That's it. I think I'm forgetting why we needed to send all and why just sending one was not enough. I'm forgetting that. Let's see if this works. I'll have to think about it.
Yeah, I mean, I think we can all, sometimes like I do one of these and like I can't because like working and like literally 10 minutes later I like post from the Discord like, oh, I was doing this like silly thing. So I mean, we could definitely like just kind of break and come back to it. But I think anyway, the like most important thing of all this is like there are hard problems in distributed computing, but it's nice to be able to work on them and just work on them like we're doing now instead of like recreating an entire like node and communications modeling of that infrastructure yourself. So it's really cool to do that. And I think we've seen in this that like we've been able to do it in a super ZIO idiomatic way where like we're using ZIO app and we're using services and we're using ZIO, we're using all the things we're used to. So it's really nice that we don't have to go to some other language to do it, and we don't have to like do some kind of give up on the things we're used to for it. So I think that's really cool.
Agree. Yeah, and it's quite fun, to be very honest, with ZIO's
Yeah,
concurrency
100%.
constructs like the promise, STM, and all that. You get a lot of power to solve these challenges.
Okay, so I mean, maybe let's just do a little check-in here of like, for anyone in the audience, this is your chance. If you have kind of a question about this framework or anything else that you want to ask, now's a great time to ask it. And then I think we can probably break here, and it can be a kind of a fun exercise for the group or for you to kind of we can follow up on the individual exercises. I'm just going to check in the chat here. It looks like it's a pretty silent group, which usually actually means people are happy and understanding what's going on. But I always joke with people of like, oh, we're super introverted, but I think people are just getting it. So I'll do one more check. But yeah, it seems like don't have any questions here. So I think this was really awesome. I mean, I think this is a really cool tool, and it's awesome that it exists in the ZIO ecosystem and that you were just able to kind of go off and create it. And I think we can see a lot of the work you've put into it around using things like those context functions and kind of giving us like really nice ways to kind of take advantage of that stuff and like have access to the context within that function or the partial function. So I think there's a lot of cool stuff here, and I'd really encourage everyone to check it out. All right, well, thanks so much, everyone, and have a great weekend. And thank you again for staying up. I know it's late for you, so really appreciate you joining, and was really happy to be able to have you on here.
No worries. Thank you very much. This was fun.
All right, take care.